Hi girls, I'm going to be talking to you today about matter and specifically measuring matter and how to do that. If you already did your vocab for the day, then you'll know that matter is anything that has some mass and takes up space. And for our purposes, what we're talking about is that matter is anything that's made of atoms. The atoms are the smallest building block of anything that you can see. Well, not anything, but most things that you can touch or feel are made of atoms. And matter is anything that's made of atoms. So all of these things, air, this rock, the water, this little pangolin cutie, all of these things are made of atoms, and so they are matter. Like I said, matter is anything that has mass and takes up some space. Light and heat are not matter. Those are kind of two of the big ones. Most of everything else that you see and hear and touch is matter. There are several ways that we measure matter and talk about matter. The first one is mass. We can talk about how much matter is in a substance. And what we really mean by how much matter is how many atoms. So how many atoms are actually in a substance. Volume is another way of measuring matter, and that addresses the issue of how much space the matter takes up. So some kinds of matter take up a lot of space, and some kinds of matter take up a teeny tiny amount of space. Density is another way that we talk about matter, and density addresses the issue of how tightly packed all the atoms are. So all matter is made of atoms, but not all matter is equally dense. So some things have atoms that are packed really, really close together, and some objects have atoms that are relatively spread apart. Density, it addresses how tightly packed the atoms are. So I wanted to talk to you guys today about mass and weight because that's something that confuses a lot of people. Some people think that mass and weight are really the same thing, but they're not. If you look here, mass is measured in units called grams. This big elephant is 2.3 million grams, and this tiny little mouse is only 25 grams. They are both made of atoms, but one of them has a lot of atoms and the other one has just a few. Mass is measured using a scale, but as we're going to talk about in a minute, that's not to be confused with weight. Mass has to do with how many atoms are in something. So if an elephant goes to the moon, he will still have the same number of atoms that he had before, but he will not weigh the same. And that's kind of what we're going to be talking about. The mass of an object does not change no matter where it is. So like I said, if this big elephant goes to the moon, he will still have the same number of atoms in his body unless he like loses a leg or something. It doesn't change no matter where he is. But weight does. So weight is the force exerted on a body by gravity, and weight is measured in newtons. So weight is the amount of force, if you look at this little mouse, that is exerted on this mouse by the earth. Newtons are the measure of force. 1 Newton is 100 grams. So I'll give you guys a second to figure out what 25 grams is, how many newtons that would be. And hopefully you said it was 0.25 newtons because that is the correct amount. There you go. So the more mass something has, the more it pulls other objects toward itself. That's what gravity is. So if you look at the Earth, this is how many grams it has. It has 5.9 times 10 to the 27th grams. That's 5.9 with 27 zeros after it. So it has a lot of mass. So it pulls other objects toward itself quite hard. The mouse, on the other hand, only has 25 grams. So even though it has gravity, it doesn't have very much. All things that are made of matter have gravity. All things that are made of matter pull other things toward themselves, even, for example, human beings. Human beings all have gravity. It's just that the gravity they have is so small that we can't feel it acting upon us. But everything that has mass has some gravity, and the more mass it has, the more gravity it has. So if a mouse goes to the moon, and let's say on Earth he weighs 25 grams and his mass is 25 grams, when he leaves and goes to the moon, his mass will still be 25 grams because he will not have lost any of the atoms that were part of his body, but his weight will no longer be 25 grams because he's going to a place where the gravity is different. So the picture I was going to show you before, this is an astronaut leaping on the moon. The point that I was going to try to make is that the reason this astronaut can jump really high on the moon is because the moon has so much less mass than the Earth. The less mass something has, remember, the less gravity it has. So the moon does not pull as hard on the body of the astronaut as the Earth does because it has less mass. The same thing with all the other planets in our solar system. This mouse has a mass of 25 grams, and he will have a mass of 25 grams no matter where he goes, as long as he doesn't lose part of his body. But he will not weigh the same. He will not weigh the same, for instance, if he's on Jupiter instead of on Earth. And if you look here, you can see the size of Earth as compared to Jupiter, and you will quickly be able to understand that Jupiter is massive. It has lots and lots and lots of atoms in it. And when something has lots of mass, it has lots of gravity. So the mouse will be pulled harder by Jupiter down toward itself than it would if it were on Earth. So it's going to weigh much, much more on Jupiter than it would on Earth.